All right, now we're going to go through the graphing section of the polars test. First note that all these y's are supposed to be r's. I don't know why that happened, but so I got our equation r equals 4 sine theta plus 4, and in class we usually had it written this way too. R equals 4 plus 4 sine theta. Exact same equation, just kind of rearranged. So I'm going to graph both the rectangular and the polar. The midline is 4, so that's here. It has an amplitude of 4, so it goes all the way up to 8 and all the way down to 0. And because it's a sine graph, it'll start at the middle, then at pi over 2 it'll be at its max, at pi at the middle, 3 pi over 2 at the min, and 2 pi at the middle again. So our rectangular graph looks something like this. So let's plot points on the polar graph then. At 0 radians we should be at 1, 2, 3, 4. At pi over 2 we should be at 8, 10, 9, 8. At pi we should be at 4 again, 1, 2, 3, 4. And then at 3 pi over 2 we should be at 0, and then finally at 2 pi we should be back to 4. So if you followed it, it went something like this, this, then to the pole, and kind of bounced off and back. And if you recognize, that's what we call a cardioid. And you can always recognize that's going to happen if it kisses the x-axis, because that means it's going to kiss the pole. So let me show you what this looks like if we do this on the graphing calculator, which I'll pull up here. So if you're going to graph the polar equations on your calculator, make sure you're in the right mode. You should be in radian mode, and you want to go over to polar coordinates. In y equals now, you can put in your polar equation, which is 4 plus 4 sine. To get the theta button, just look right next to alpha, and you'll see that there is a theta symbol there. So I'm going to pick theta. And then before I hit the graph button, I'm going to hit zoom. I can click it. I'm going to go down to option 0 and hit enter. You could also bring it up by just hitting the number 0. And this is going to give you a nice window that'll fit the graph perfectly. And so for the test, I'd expect you to show me this picture with one point all the way over at 4, up at 8, here at 4, and then coming to the pole there. Now let's try this again for the next one. So once again, this should be an r equals, not a y equals. It has a midline of 2, and it has an amplitude of 6, so we go up to 8, and we go down to negative 4. It's a cosine graph, so it starts at the top, goes to the middle, goes to the bottom, goes to the middle, back to the top. It looks something like, this is not the most beautiful graph, but something like that. So if we're going to copy these points over into the polar grid, the first point was at 0 radians, 8, 10, 9, 8's right there. At pi over 2, it should be at 2, which is here. And then a little bit after pi over 2, it's going to go to the pole. Then at pi, it's going to be at negative 4, which is 1, 2, 3, 4. Oh, wrong way. Because remember, negative 4 means you go 1, 2, 3, 4 to here. Then we're going to go back to the pole somewhere around here. And then at 3 pi over 2, we should be back to 2. And finally, at 2 pi, we should be back to 8. So if you followed it, it went something like this, then to the pole, then it went to this point out here, then back to the pole, and then through these points. So this is our limison with an inner loop. Once again, if you want to see what that would look like on the graphing calculator, which you get to use on the entire test. Bringing up this calculator is a little annoying. There it is. Okay, y equals, I'll put in 2 plus 6 cosine theta. And once again, I'm going to go to zoom and pick option 0. And hopefully it'll give me a pretty good picture. And there it is. All right, let's go ahead and look at the third one. We've got what's supposed to be r equals 3 sine theta minus 4, or r equals negative 4 plus 3 sine theta. That's the way we usually wrote it. So it has a midline down here at negative 4 and an amplitude of 3. So it goes up to negative 1, as far down as negative 7. Positive sign, so it starts in the middle, goes up to the max, back to the midline, down to the baseline, back to the midline. What you should notice in this graph is it doesn't cross the x-axis. like the last one. So I think this one's going to look more like the dimpled kind. Let's see if I'm right. So at 0 radians, we're supposed to be at -4, which means we go 4 this way. 1, 2, 3, 4. At pi/2, we should be at -1, which is down here. At pi, we're supposed to be at -4, which is over here. 1, 2, 3, 4. And then at 3 pi/2, we should be at -7, which is way up here. 10, 9, 8, 7. So before I connect them, I'm going to switch over to the graphing calculator to show you what this looks like. So I'll type it in the way it was given to me. Y equals 3 sine of theta minus 4. You could write it the other way too. I do zoom, pick option 0. Let's see what this looks like. And yep, it is the graph that appears to have a little bit of a dimple. So it's going to look something like it goes up through this point, to this point, down here, through, and back around. And so, you know, I actually didn't draw that in the right order. The first point was this point. It should have actually drawn this part first on the bottom left, and then this part, and then around. But that's okay. So that's what the graph looks like. This is a dimpled limacon. Okay, only a couple more to go. If we look at the next one, we've got y equals, just 2 more. Y equals -2 cosine theta plus 6. So that once again should be at r equals. The midline should be at 6. The amplitude is 2, so it goes up to 8 and down to 4. It's a cosine, so we normally start at the top, but because it's negative cosine, we actually start at the bottom. Then we go to the mid, then to the top, then to the mid, then to the bottom. So it looks something like this. All right. So then we'll take these points. At 0 radians, we should be at 1, 2, 3, 4. At pi/2, we're at 6. So that's at 10, 9, 8, 7, 6. At pi, we should be at 8, which is 10, 9, 8. And then at 3 pi/2, we're at 6 again. So 1, 2, 3, 4, 5, 6. And finally at 2 pi, we're back to 4. So if you followed what we did, it's sort of like this. That was not very round. Writing on a tablet is not always the easiest thing. Oh my goodness. Yeah. This looks awful. Like it should be more like rounded. Do your best with these. I know some of you who don't think you're very artistic will have a hard time with these. But that's roughly what that graph looks like. Once again, I'll try to pull up the graphing calculator to look at it. And I really do mean try, because it's difficult. So y equals -2 cosine theta plus 6. I hit zoom, 0, look at the graph, and hopefully it looks like what we just sketched there. Yep. Now you'll notice that there doesn't appear to be a dimple here, and we're not really going to get into this, but some of these graphs here that aren't inner loops or cardioids don't always end up having a dimple. That's not something I'm going to assess you on. There is a way that's very complicated to know if the graph is going to be dimpled or not, but we're not going to cover that. So don't worry too much about that. But this is just a regular old limacon. All right, one more graph to look at. And so you're thinking of all the graphs we've done. We haven't done any flowers yet. So this is what a flower graph equation usually looks like. Its midline is 0, which is nice. Its amplitude is 4. And then what's going to happen is it has 2 cycles within 2 pi. So that means it's going to go twice as fast as a regular sine function. So there's 1 cycle, and there would be 2 cycles. And then creating the rows graphs from the rectangular is a little bit of a pain in the butt. So I'm not going to really ask you to do that. But things that I would expect you to know is that because this number is even, that means we should have 4 petals. And because it's sine, we'll have no petal on the x-axis. If this had been an odd number here, if this had said like 3, then there would be exactly 3 petals instead of the doubling property. So you should know that kind of stuff. If I go over to the graphing calculator, we'll get a good sketch of it. Come on, graphing calculator. Come on. Aha. We'll go to y equals 4 sine 2 theta, then get rid of the stuff at the end, and hit zoom 0. And then you get a graph that looks like this. Now, what I do expect that you know is how far away this point is right there. Each of these petals should be going about 4 away. So if you count out 1, 2, 3, 4, that's as far out as each petal goes. So what I do sometimes, and you're more than welcome to do this too, is I make a little circle here. This is not part of the graph, but it just helps me kind of go, all right, so I need a petal, I need a petal, need a petal, and then I need another petal. Okay, that last petal was pretty bad, but that's okay. So that's what you should be able to generate on the test, is that you know y, r equals 4 sine 2 theta, so you have 4 petals because you double for even values in front of theta, and then this number in front tells you how far out the petals go. So what I don't want to see on the test is that you just sort of like make random sized petals that go out as far as you want. Like you just make one that goes out to 8, one that goes out to 2. Like no, you should know that each of these petals go as far out as 4, and that's because of these values here are sort of the edges of the petals. All right, that's the end of the review guide for the Polars test. Hopefully you enjoyed this.